Hi there. So today we will look into what Internet of Things is, like how does it work with AWS and then how do we get started with it. But to begin with Internet of Things, we know what internet is. It's like a network of connected devices, which is like it can be computers, smartphones, wearables. We know all these gadgets that can be connected to internet. Now we know that these are devices which we can consider it as things which has been there already. But why is there a buzz of Internet of Things right now? Now when we talk about Internet of Things, it is like a little bit different in terms of when we compare it with computers and smartphones, because in addition to doing a lot of things that computers can do, IoT devices has this ability to sense the real environment and also take an action based on it. So whenever we have devices that can sense and act, that's when we say like it belongs to the category of Internet of Things. Now, when was this term coined? It was like in 1999 by Kevin Ashton. He was working on a presentation for Procter and Gamble, and he was working with RFID tags and stuff like that. When he was like working on that particular project, that's when he coined this term Internet of Things. So although like it started with RFIDs, but it has gone way beyond that, and we will look into some of those things as we go forward. And we know that, I mean, although like he coined the term in 1999, IoT is not just about one particular technology. It has like so many things that encompasses into this one technology. Now, some of the things we can say is like it has communication, as in it can be like 5G, GSM, LoRa, all these different types of communication. It also involves computing, networking. How do we sense and act depending on the type of sensor, what we want to use, and what action do we want to make. And all this communication, when this happens, like security is also of prime importance. So all these things put together is what builds the Internet of Things solution. Okay, now moving forward, let's just take a little bit dip into uh, the architecture of IoT system. So whenever we have like any IoT system, this is how it will typically be looking like. So we have devices at one end of the spectrum. So these devices has like a small microcontroller, probably a sensor and an actuator attached to it, with some communication module that wants to talk to the cloud, where there can be applications running, where there can be storage that where we record the sensor values and stuff like that. Now most of these IoT devices that we talk about, they are like it has like one primary characteristics, which is it's a resource constraint. It does not have unlimited power or bandwidth or internet connectivity and stuff like that. So that's the reason why we usually prefer having something called as a gateway. Now gateway provides uh, like a gateway into the internet for these resource constrained devices. So this is how typically any IoT system would look like. What is it used for? Depending on the industry, depending on the use case, it will vary very differently. But overall, this is how it's going to be like most often. Okay, so just going a little bit further with the characteristics, I was just saying that this is power constrained because most of the IoT devices, they are meant to do a specific task. Now, we don't want to be allocating a lot of electrical power to it. We want stuff to be done in like least amount of power consumption. For example, you may have seen all these beacons, Bluetooth beacons with one coin cell battery that can last for a couple of years and things like that. So power is of like one of the uh, prime characteristics of IoT devices. Similarly, bandwidth, how much data does it send and receive often? So that's something again to look at. And then computation power, because we do not want to spend a lot of power in these IoT devices, it creates this constraint of how much computation capacity do we have. Like we cannot have like probably 2 gigahertz processor, octa core and things like that running in an IoT device, because we want it to consume very less power. And similarly, we want it to be in a very compact size. We want it to be having a low cost, and then it should be programmable and reconfigurable. So this is like a wish list, but yeah, most of the, I mean, during the development, most of these IoT devices allows that. Now let's just take a look into what IoT platforms are available. When I say platforms, these are like microcontrollers with some peripherals that acts as a gateway to connect to the cloud. Now, this is an Arduino 33 IoT device which has Bluetooth and Wi-Fi involved in it. Like maybe you might have seen Arduino Uno, but it's limited because it does not have any communication interface to connect to the internet. Similarly, there's Raspberry Pi, which is like very popular. Again, it can run a full-blown operating system within that. And similarly, like there is ESP32. This is one of my favorites. I use it like a lot of times. It is like low cost. It has Bluetooth and Wi-Fi, and there's like huge support for this particular microcontroller platform on the internet. And even in production, this device is used in like millions of places. So this is like a really go-to for me in terms of any microcontroller platform. From ESP32 is what this new platform has been derived, which is like M5 stacks core 2, and there's like one of this hardware that's meant especially for AWS. This has like ESP32 processor plus a lot of peripherals that you can directly get started with. It has like a very nice looking display which is like touch enabled. It has a few sensors, and then it gives you like so much of connectivity around it, and you can program it with different programming platforms like UiFlow, Arduino, FreeRTOS, MicroPython, and stuff like that. Okay, and talking about the architecture of IoT devices, like, so I just wanted to let it be a little bit flexible because, like, in any of these IoT device, in order to make it like a full-fledged IoT device, we essentially need a microcontroller that can do the computation, and then there has to be this part, which is like the important part, which is like either we need a sensor or an actuator that can sense or perform any action on the real environment. So this gets connected to the microcontroller, and similarly we also need a communication device. Now depending on the use case, like this can really vary. Most of the IoT devices, like they work on either Wi-Fi or Bluetooth BLE, and one of the very popular communication network these days, it's like based on LoRa. So it consumes very less power. It has like very high range, like between 2 kilometers and 11 kilometers. And it is like a really good platform for IoT systems. So like, and there can be more. There is NB IoT, there is like 5G we can use. So all these three things put together is what makes like the architecture of IoT devices. Not to forget, all this has to be enabled with the power layer. And when I say power, it can be a battery plus a battery management IC, things like that. So all these things put together is what will make an IoT device. When we look into these three platforms, like this, and this does not have any power management capacity on their own, but this M5 Core 2 for AWS, this comes along with a battery and like battery management kit. So all those things put together, it's like one package of a complete IoT device. Okay, so why is there so much buzz around Internet of Things? Like, although this talks about like 2020, but this pretty much has like a lot of technologies that are going to be like very important in the near future. For example, like we are talking about IoT, and then like we also know that AI is like buzzing around the world, and then blockchain, AR, VR, 3D printing, drones, and robotics. When we look into all these technologies, the uniqueness of IoT is that whenever IoT works with any of the other technologies here, it brings unique value. For example, IoT along with artificial intelligence, it can like bring predictive maintenance, it can make anomaly detections happening, and then it can also provide like edge intelligence and stuff like that. Similarly, working with blockchain, it can provide like smart supply chain, so which is like very popular. Customers will be able to like track their goods real time, where is it in the supply chain. Similarly with AR/VR, it can be used where in order to do training like in 3D models and stuff like that. So yeah, like IoT, wherever it goes, it brings unique proposition. So that's something like I love about IoT here. And the market of IoT is like growing day by day. So that's one more reason to like learn about IoT and then use it. And this is one of the things I wanted to mention as well, which is like, although cloud computing is not here whenever you look into any of these technologies, it works very well when it is like backed with the cloud computing technology, because underneath all these things, if we enable it with cloud computing, we don't really have to spend a lot of time in order to build like the compute infrastructure. We can just trust on the cloud computing, any service provider, so that it will take care of the computing demands, and then not just computing, storage, bandwidth, all these things. And we will only be charged based on like the amount of usage we are making on this public cloud. So that's the reason why I got started with AWS IoT. Otherwise, like I was a person who would be building like my own servers, my own communication channels and stuff like that. But not all the time building our own servers is like a good solution. So that's the reason why I moved into AWS IoT. And now this is where we will look into like what are some of the IoT services in AWS that are available for us. Now, AWS calls it like AWS IoT Universe. It has like different offerings for different industries. Like for home, it has like different types of architecture that are available in order to make anything IoT enabled. Similarly, at work, in production, or in community, for transportation, for smart city. So like obviously we can design our own architecture, as well as like AWS has some of the templates to get started with as well. Now, AWS IoT like splits its services into these three different categories. Like one, it starts with the device software, whatever it goes into the microcontroller, and then how do we manage on premises or like within the devices. And then there is like control services. So how do these devices communicate with the AWS IoT infrastructure? So on the cloud, how will we like let these devices get discovered? When we do that, like we have to address all these things. How do we control the connection? How do we manage these devices? And then how do we make sure these devices communicate amongst each other, or like the devices to the cloud communicate in a very secure manner? And once the data gets to cloud, and then what do we do with that data? Because at that point of time, we will only have the data like to make it as an information or like an actionable information. There is like a few data services that are available on AWS. So these are like the three categories of AWS IoT services available in AWS. Now, going a little further, like AWS has this virtuous cycle for IoT, where these are like the different services. For device software, we have FreeRTOS, IoT Device SDK, Greengrass, Device Tester. So we will look into like briefly each of these things. Where can we use it? Like how does it differ from one another? Because some of these things may look very similar. Now, the best place for you to like learn more about it and get started is like you can just go to AWS IoT website, and then you can see what are the different AWS services. Like for device software, these are like the primary two services that are available. FreeRTOS and Greengrass for edge analytics and stuff like that. And then similarly for getting these devices to connect to the cloud, we can use IoT Core, Device Defender, and we will obviously make use of device management as well. And once the data comes to the cloud, and then we will use IoT analytics or IoT sitewise or IoT events in order to like connect these devices, like build intelligence out of or derive value out of that data, whatever we have been collecting. And similarly, just like how we have this virtuous cycle, also like in documentation of AWS IoT, you will find that like in each of these categories, these are the services available. And in the following, you can also like just go through like a quick read through of what these services do, but I'll be doing that as well here. So let's just look into like each of these categories and what services are available in that, and what value does it give to an IoT solution. Now, when we talk about device software, one of the basic most service that AWS offers is like FreeRTOS. FreeRTOS is like a real-time operating system. One of its version is like FreeRTOS. Now Amazon adopted that FreeRTOS, and then it is providing a lot of resources in order to configure these IoT devices so that it can be easily onboarded onto AWS IoT ecosystem. Now, similarly, just like how there is like information on this AWS IoT architecture and stuff like that, for FreeRTOS, like this is how it works. Like we will have our own hardware, and then the vendor drivers, whatever comes along with it, like bootloader and stuff like that. On top of it, we will have the FreeRTOS kernel and the internal libraries, on top of which we will like decide which of these peripheral stacks do we want to have, and then on top of which like we will have these communication protocols, and then our application will sit on top of that. So when we choose a microcontroller, so this is like the journey of how we develop with FreeRTOS. We select which microcontroller do we want to work with, and then we go on further with deciding the operating system and the libraries, and then we start developing the app so it can be like onboarded onto AWS ecosystem. So that's what FreeRTOS is about. And then not all like, okay, one more thing about FreeRTOS is that it is based on C programming language, and then uh, it's not very easy to like develop an application based on RTOS for somebody who wants to quickly get started with like writing a program for these embedded devices. They can make use of these IoT device and mobile SDK. So it gives you like a library for maybe Arduino or for your terminal for Raspberry Pi, so that you can just program it quickly using the libraries that AWS IoT device SDK provides, and then you can onboard that device onto AWS ecosystem. So that's what is IoT device and mobile SDK. And we will be using this one during the demo as we go further as well. Okay, and this is like, IoT Greengrass is one of the interesting device software again. The way it works is like, let's say we have like two premises. One is like the on-premise, and we also have AWS Cloud. Now, if we configure each of these devices on premises, let's say we have like multiple devices that we want to onboard to AWS. Now, if we have like multiple such AWS devices we want to onboard, so we will have created, and then with device management tool, we will have like onboarded those devices into AWS IoT. Now, instead of, if these two devices within the premises need to communicate with each other, the way it would have worked without Greengrass was like one device would have like sent the data to AWS Cloud, and the other data should have received from the AWS Cloud, which is like a very not good way of communicating, because like they both are in the same place, but the data had to travel like for so long. That's the reason why Greengrass is like one of the services that tries to bring some of the AWS IoT's core capabilities on premises. So that's what Greengrass does. Now, Greengrass brings a lot of stuff along with it. Not everything that AWS IoT Core can do will the Greengrass also be able to do, but things like communication amongst the devices, making like a Lambda function execute within the on-premise network, uh, like performing some kind of like machine learning inference and stuff like that, we can easily do with Greengrass. And the way Greengrass works is like whenever we want to implement Greengrass group within the premises, this is how it works. Like we usually call it like Greengrass group because it brings in like a lot of stuff. First thing, it's like we will need to have a core for the group. So core is like the core processor of the group. So any device that wants to communicate amongst each other, or like that wants to send data to AWS IoT, it will have to publish its messages to the core, and the core will take care of publishing those messages to AWS IoT Core. And then we can have like these devices connect to core, and then similarly we can if these devices need to communicate amongst each other, we can create subscriptions. So these subscriptions will like make sure that the publishing device will whenever it publishes any message, the subscribing device will get those messages. And similarly, like whenever we want to have like some lambda function run, we can have those things configured depending on either like whenever we publish a message, we can say a lambda function should be triggered, or depending on like period, just like how we do it with CloudWatch events, we can do it with uh, green grass group as well. Like we can set a timer, like a cron job, this is what exactly will be happening in the green grass core. So these lambda functions essentially will be executed on this core device. And similarly, when we have like these devices in need to connect to or communicate to other APIs like Twilio so that it can send SMS or make calls and stuff like that, Greengrass Group also provides these connectors. So these connectors will allow us to connect the core with such other API service providers. And we can have like some resources as well. For example, we can have like the machine learning models or some CSV files and things like that that can be part of the core. So whenever we want to perform some kind of machine learning inference, we can do it directly on the core without having to get the data to AWS IoT and perform any machine learning inference there. And so like this core and the AWS IoT Greengrass group that's like on the cloud, they will be communicating with each other. So like whenever we want to update the core, we will have to like go to AWS IoT on the cloud, and then we will be like changing the configurations, and then we will be deploying on this group so that the changes will take effect after that. And then whenever we have like these FreeRTOS devices or green grass devices configured, if we want to check like is it working with, is it functioning properly, then we can use this AWS IoT device tester. So it's just like a testing software that makes sure that the configurations that we have created for these devices, will they be doing the job that we are expecting it to do. So that's what is IoT device tester. Like these were like the four uh, device level softwares or services that are available on AWS. And now let's look into what connectivity and control services are available in AWS for us. So IoT Core is like the primary AWS service that supports like communication between the devices and the AWS infrastructure. Now the devices can publish to IoT Core or subscribe so that it can receive messages from the AWS IoT. We will dive deep into this as we go, because this is like one of the primary services that we will use in order for any device to connect to AWS. So yeah, more of this will come as we go. And then device management, it's like, so the way we connect any IoT device to AWS, so we first go to IoT Core, and then we use this device management tool so that we can register the device, and then we create these or generate the certificates that can be like used on the IoT device. So that creates the authentication mechanism. So device management allows us to like register the devices on AWS IoT Core, and then we can organize them depending on the types and groups and stuff like that. And then it also allows us to perform jobs on these IoT devices. So we can update the device's firmware with over the air updates and stuff like that. And then like we can also have like a really good management tool. So one place we can see like how are these devices performing different things, when was it last connected, how many messages has it been publishing. So device management service allows us to like have a view of all the devices on our AWS account. And device defender is like a service that makes sure that devices are communicating with the IoT core in a secure manner. So depending on the type of configuration we create, the device defender will like make sure that is the device, I mean, not more than one device should be using a particular certificate in order to communicate to AWS IoT Core. If multiple devices use a similar certificate or the same certificate, it will create notifications and it will let the user know that there is something wrong going on. And if these devices, like, let's say at one point of time, I was getting uh, messages from the device with this particular IP address, and suddenly all of a sudden it has changed its IP address, which is like 200 300 kilometers apart, which may not be the real case. Like this could have been some kind of phishing in IoT devices, which is like a security concern. So device defender will be able to like understand all those things and create notifications for us. And IoT Things Graph, it's like a very interesting service again. Now, when we have like multiple IoT service devices that are there in our account, we may want to have like a flow of how these devices connect to different services so that we actually build like a really good infrastructure. Now, similarly, like you can see here that there is like a CloudWatch event trigger that generates a trigger every 60 minutes, and then that triggers a lambda function, and that lambda function makes sure that it communicates with the IoT device to realize like if it's the day or the night, and then depending on the time it will actually like make the this IoT device, if we consider it to be like a light bulb, it will either turn on the light bulb or turn off the light bulb, things like that. So when we want to create a flow of process like this, we can use Things Graph for that. So these were like the control and connectivity services that are available in AWS. And now let's look into what data analytics services are available. So IoT Events is like a very basic uh, service, but it's like very powerful because like every message when it comes to AWS IoT Core, there we can create rules and we can define triggers so that if the incoming data is like beyond the threshold or things like that, we can generate notifications, we can trigger lambda functions, we can do like a number of stuff depending on the data that we are collecting in the IoT event. So that's what IoT events does. This is one of the examples. So like we have this IoT device. Now, in order to get this IoT device onboarded with the IoT Core, we first generate the certificates and then we provision the certificates on this IoT device. Then this device like collects the GPS coordinates from a satellite, and then it keeps publishing it to AWS IoT Core. So when it goes to AWS IoT Core, this triggers the AWS IoT events. Depending on the coordinates, it will be able to say that is it in the boundary or like is it on our horizon or not. If it is like on the horizon that is available for me wherever I'm in the earth right now, it will create a notification and then it will just inform the user. Things like that we can do with AWS IoT events. And Sitewise is like another AWS service. If we want to like collect the data, so Greengrass allows us to perform some kind of edge analytics as well, I could say, because like there is a core that has the capability to like collect the information, process that information before it sends it to AWS IoT Core. Now, Sitewise is like whenever we have like large number of devices on premises, when we want to collect the data, store that data, organize the data, and then do the same thing on cloud as well, that's when we use Sitewise. So Sitewise is like it can only collect, store, and then organize, and then it can also like send it to AWS IoT Core or to AWS IoT side. So that's what Sitewise does. This is like one example. So when we have like many AWS IoT devices like here, and then it wants to send it to AWS IoT, I mean AWS cloud, but before it sends it, like we can have like an IoT Sitewise edge gateway here. So this will collect the data, it will organize it, and that will take care of how this database gets synchronized with the AWS Cloud, AWS IoT Sitewise service. So once the data comes here, like then we can fetch that data into IoT Core, and then we can create different rules. So we perform different actions on the data that we collect. And this is like one last service of AWS IoT, which is like IoT analytics, and this is like very powerful. So whenever we send data to AWS IoT Core only collects the data. If it has to perform any action on it, it will take the action. Otherwise, like it really does not store. If we want to store the data from AWS IoT Core, like we need to create a rule and then forward it to other different AWS IoT services in order to store or perform any IoT events or like process that data. So IoT analytics is like one of the services which allows us to get the data from IoT Core. And then in IoT analytics, there are like different things we can do. We collect the data and then we kind of do pre-processing of the data and then we store it. So this storage can be happening like either infinitely, or we can define the period of how long should the messages be stored in IoT analytics. Like this essentially uses like S3 buckets in order to store the data. So once it comes to the data store, depending on its lifetime, it will store that data. But after that, we will also be able to like create data sets out of it. So these data sets will allow us to like uh, create customized data sets, so we can like use that for creating visualizations in QuickSight, or maybe we can use it to do some kind of ML modeling and stuff like that. So that's what IoT analytics allows us to do. And here is like one example of how we use it. So we have like smart home. There is like a sensor data that comes to IoT Core. IoT Core has a rule that forwards it to IoT analytics. And here in the channel, we essentially like ingest the data. In pipeline, we pre-process it, and then in data store, we store it. And then after that, we create custom data sets out of it that can be used for visualization in QuickSight, or for any ML purposes in Amazon SageMaker. Okay, now let's look into a little bit more about what AWS IoT Core is like and how will it be helpful for us. Now, IoT Core has like these different services that are like within it. So if you just go back to this uh, documentation part, it also tells you like what can you do with IoT Core. Like you can have devices that you can create on IoT Core, and then these devices will be communicating with the message broker. You can create a rules engine so that this rules engine, whenever a message comes, it will trigger different other AWS services. You can create device shadows. It's just like retaining those messages for a particular device. You can do that on using device shadows, and then you have like a layer of security and identity access management for all these things. And this is how we essentially build these IoT applications. Now, we will also be looking at each of these things as we go. So we will use like a device SDK. I will use something based on a MQTT client, and then we will configure it to connect to AWS IoT using its device gateway, which is essentially like the MQTT broker. I'll talk about what MQTT is as we go. So we will be able to connect to that using the authentication and authorization. It's like the certificates that we create on AWS IoT Core. And once we get the data into AWS IoT Core, we can then retain the messages either on the device shadows, or we can like trigger the rules engine so that we forward those messages to other different AWS services. And then we can also have like a device registry where we can manage like what type of devices do we have, like what are the groups of devices or the things that we have. So we can do all those things with device registry here. Okay, now let's quickly look into how does IoT Core look like. So if we just go to AWS's Management Console and then go like search for IoT, we will find this IoT Core service. I'm currently in the North Virginia region, but so if you use some other region, it will I mean, the UI will look a little bit differently, but the functionality wise, like whatever services that I'll be using it, it will be pretty much available in every region where there is support for AWS IoT Core. If I want to get started with creating devices, so we can click on manage, and then here we get these options. What things do I have on my accounts? I don't have anything yet, but okay. So we will create one of the devices and we will see how it goes. And then we can create thing types. For example, if there are attributes for a particular thing, maybe let's say I have a smart bulb, maybe it has a brand to it, maybe it has wattage to it. So these things we can create with types. So let me just quickly create a thing type. Let's say I have like bulbs, and then I can have like searchable attributes for it. These searchable attributes we will be able to like search on the AWS IoT console itself. So currently we do not have any searchable attributes, but let's say I want to associate this with a brand, and then what is the wattage of it. We can have up to 3 searchable attributes for anything type. I have created 2. So let's just do that and then create things. So I have one thing type, and similarly I have thing groups as well. So let's say these things can be like part of different assets of a company. Maybe like there are multiple IoT devices that are going to be there in a particular lab. So we can create that lab as a thing group. So we can uh, have like different policies for those things in that particular lab alone. Okay, let me just go back and then quickly create a thing. So I'll click on register a thing and then create a single thing. Let's call this like bulb 101. Now, currently, like I can associate this with anything type or with anything group, and I can also have like searchable attributes as well as non-searchable attributes for these things. If I select the thing type as bulb, it will automatically populate that it has these key. For example, let's just do my bulb is like of Wipro brand, and then it has like 40 watts and stuff like that. So I can have up to 3 searchable attributes. So I can still add one more, but because I have made it to be part of bulb thing type, I cannot add more searchable thing attributes. I can only add non-searchable thing attributes. For example, maybe let's say I'll say color and then yellow. Okay, so I have just given the name. You can either select the type or not, it's up to you. And then when we click next, it gives us different options of how do we want to authenticate this device. So either we can create certificates here, or we can use our own certificates, like depending on who's the certifying authority. But I'll just do this thing which is like one-click certificate creation. So I'll do that. This will create a certificate, and it will also give us like a public key and a private key. So I will download this thing. So click on download, and then let's say I download it here. In desktop I have this IoT Core demos folder, so that's where I'm like saving it. So I'm downloading all the 3 files, but you need one more file along with this, which is like the root certifying authority certificate. So when you click on this download, it will take you to another page where you need to like click on this RSA 2048-bit key. When you click on that, it will give you this. So you just need to copy paste this and then probably paste it to your notepad or text edit, and then save it with a .pem extension. I have done that already. I'll show you how it goes as we go. Okay, and once you have done this, like make sure you click on activate. Only then this IoT thing will get activated. Okay, so we have activated the thing, and then we need to attach a policy to it. So there are like 2 things about IoT devices in AWS. First, we kind of create the device, and then uh, the way we connect this device, when we want to connect, there are 2 things that will come into picture. One is like the authentication. So what's the mechanism with which we will be able to say authenticate? What's the mechanism with which we will be able to say like this is the device that I wanted to onboard? That's when we will be using the certificates that we just downloaded. And then we will have this concept of authorization. So the authorization talks about like what are the things that this device is authorized to do. Like, is it allowed to connect to AWS IoT Core? Is it allowed to publish? Is it allowed to subscribe and stuff like that? Currently, we do not have any policy, but I'll just click on register thing, and then let me show you what we can do with the policies. Like, so when you click on secure and then click policies, I do not have any policy yet. So I'll click on create a policy and then let's call this. Okay, first let me show you what are the actions that we can do in IoT Core. We can connect, we can publish, subscribe, receive, or for the thing shadow, we can update the thing shadow, get the thing shadow, delete the thing shadow. These are the actions that we can make on AWS IoT. We can have these policies. If you want to have a device perform all these actions, you can just click on IoT star, and then that will allow us to like perform all the actions. So let me just like stick with one here. So when I click on IoT Connect, it tells me that I need to replace this with a client ID. So my client ID is like bulb101. Let's just make sure, because like if this is wrong, it will not allow us to connect and stuff like that. Okay. So when I open this, yeah, bulb101, and I want to allow, similarly, let's say I want this IoT device to also publish. Now here I need to specify what topic should I be publishing in. Now this is the time when we can like quickly look into what is MQTT. MQTT is like a protocol that allows the devices, IoT devices, to connect to the MQTT server, which we call is like MQTT Broker. In HTTP, it's like a request response model. So the in HTTP, this is what happens. Like when we have HTTP, like we will have a client and then we will have like the server. Whenever the client makes the request, server has to be like live at that point of time. Only if it is live, it will like send back the response. But the amount of header bytes that gets transferred in this process is like a lot. So that's the reason why like for MQTT it will not be an ideal case. So in MQTT what happens is like we have something called as a broker, and we can have like devices all around these broker that can get connected to it, and then uh, these devices can publish to the broker on a particular topic. Whichever other device has connected to the broker and has subscribed to that particular topic, any publisher, when it publishes the message to the broker, the subscriber will get the message on that particular topic. So that's how MQTT works. And now in AWS IoT Core here, if I want to allow this IoT thing to publish to IoT Core, we can also specify that what topics are allowed. So let's say I want to allow like every topic for now, and then let's say allow here, and then similarly I will let it subscribe. Let's do this. Bulb 101 publish, bulb 101 subscribe. And similarly like subscribing is one of the things, but there is like one more action that we need in order to receive the messages. So bulb 101 subscribe. Okay, so this will allow like, this is for bulb 101. Let's say create. This will create the policy in JSON. Like it will have all those things. If you just want to quickly look at how the JSON looks like, it has like these effect, action, and resource. That's what makes this policy. And now when we go back to things, and then this thing will have like, we need to modify its security. It has this certificate. For this particular certificate, we want to be able to attach the policy. Now attach this policy and then click attach. Now if we have a device that we want to onboard and connect and publish messages to AWS IoT Core, like it will allow us to do that. Now AWS IoT Core has like one of the things within it, which is like the MQTT Broker. Now if you want to learn more about MQTT Broker, you can just go to mqtt.org, and then you can find more information there, like how do you get started with it. For example, when you click on software, what libraries can you use in order to send messages to AWS IoT Core. So I use something called as Mosquito, which is like very popular, and that's what I will use here as well. Okay, so when we want to send messages, like we need certain things. When I say certain things, like we will need like the endpoint. So what is the address of the AWS IoT Core's MQTT broker? This varies depending on the region. So depending on which region AWS IoT Core we want to use, we will have to use that particular endpoint. And we will also need the client ID, which is like the thing name. It has to be matching exactly. And then we can also have like, we also need the certificate, we need the private key, and we need the root certifying authority, that certificate, and yeah, the port number. So just like how HTTP works on 80 and 443 depending on if it's with SSL or without SSL, similarly MQTT without SSL works with port 1883. And if we want it to be like communicating based on these certificates, which is what we call MQTTS, and this is on port 8883. So we will have to also specify the port number. And after all these things, depending on if we are publishing or subscribing, we will also define like which topic are we publishing to, and then what message are we publishing. Now let me use this command prompt thing. So you can install this CLI client, which is called Mosquito not here, Mosquito. So you will find, okay, these are like the client libraries. When you install like Mosquito, it will also have like Mosquito client part that will get installed, and then you will be able to like publish or subscribe from the terminal. So Mosquito publish, let's say I want to publish, and then just for you to understand like what can we do with it, you can use help so that you can get like all these different flags. How do you use all these things? Now let me navigate to desktop and then IoT Core demo. That's where I have my for like certificate files, the certificate, private key, public key, and the root certificate here. And now let me do this Mosquito publish. First, we need to specify the host name, which is like the endpoint for our AWS IoT Core. So either you can go to things, and then here when you click on interact, you will see this thing. This endpoint does not vary depending on different things. So like either you can find this information here, or you can just go to settings here, and then you can find that information here. I have it here. And then, so where do we monitor? Like I can come to this test, and then if I want to subscribe to a particular topic, and then I can just say I want to monitor everything that is published to this topic called bulb 101 POB. So my computer is like publishing, and then I'm subscribing it on this browser. So subscribe to the topic here, like any message that comes here, it will just publish it here. Now let me click enter so that it will publish from here, and then I can see it on the terminal here. It has come. So this is how we can publish it. If I want more attributes, I can just like keep doing that. Let's say name, and then Tom, that should just print these two things. So this is how we will be able to like publish these messages. And if we have a program, it will just like make sure all the messages are coming here. I manage this blog called things.school, and if you go to that website, you should be able to find some article. Like there is one article I've created on interacting with MQTT broker that you can use. So MQTT, like there are different authentication mechanisms for us. Without authentication, how can we publish or subscribe using the terminal as well as with a Python program. If it was like an authentication based on username and password, how do we publish or subscribe to messages? If it's only with the broker side certificate, this is how we would be communicating. And this is what AWS uses, like if we want to publish or subscribe. And this is exactly what I just did as well. If let's say I want to subscribe as well, like I'll copy this thing. So, and then I'll subscribe it here, or I'll just use this, I'll modify the things a little bit here. So let's say I subscribe, the host name remains the same, which is like the endpoint, the port remains the same, CA file certificate, private key, and the identity of the device will also remain the same. But the topic I'll subscribe to will be like this one, because that's what I have created the authentication, the authorization for. And then like when I subscribe, I don't have to give the message because it will be the browser that publishes. And here I'm just like keeping on listening. Now if I come back here and then let's say I want to publish a message, so I will be publishing from the browser on this topic called subscribe, and then this is the message I want to publish, let's say, which has like this JSON message, hello from AWS IoT Console, and then when I click on publish to topic, I'll get that message here. So this is how the publish and subscribe works. So this was like the way of how I create a manual thing and then I work with it. But there is like an easy way of doing all these things. If you can just go to like onboard and then get started, this gives you like a device SDK, and then you can very easily get started with it. So like click on get started. I'm on OS X and then I want a Python SDK, and then let's say I click on next. So that creates this, and let's say I call this demo device, and then next step. So this will create the certificates, it will create a script, everything, and then it will just give us everything. It will have created a policy as well. It calls it like demo device policy, and then let me download this. When I click on this, it will prompt me to like select a place. Okay, this is the zip file it wants to download, and then when I click on save and then click on next step, okay, so this gives like the instructions on how we can get started with this script. So let me just go here and then stop from here, and then here we have this connect this. I'll unzip this thing, and then so I will have a new folder called connect device. No, everything is like extracted here itself. So the next thing I need to do is like modify this start.sh. So if we just want to see like what's there in start.sh, I'm opening this on Visual Studio Code so that we can quickly look into it. So it will try to like check if we have a root certificate. If it is not, it will download that for us, and then it will download the SDK from this GitHub repository, and then it will try to navigate into a particular folder, and this is the file that it will execute, basic pubsub.py. Now, so first I have to do this chmod +x start.sh, and then the next thing was like start the script. So I'll just say start sh. It will like download the certificate, it will download the SDK, and then it will execute the pubsub.py in that SDK that it downloads, so that it will start sending messages to us. How do we monitor that? We can just go back to test and MQTT test client. Here, if I want to subscribe to, let's say, all the topics that is associated with this particular account, I can just do that test MQTT test client. And if I want to subscribe, I just like use the hash sign subscribe to topic. So whatever devices are associated with this account, once they start publishing, messages from all the topics will be coming in here. So here we start receiving the messages in the MQTT client. So this is how it works. Now, what's beyond this, like we are not storing the data or anything here yet. This is where we can like take a quick look at how do we use the rules engine to store the data and then send notifications, use IoT events and stuff like that. So there is this tool called Learn here. You can see on the left. When you click on that and then click on start the tutorial, you will be able to see like some interesting lessons that come here. Device gateway, it's like it allows, so this device on top, device 1, it has like these 3 control buttons, RGB. Depending on which button we click, the device 2, because it is a subscriber, it will get that message and then it turns its color. So if I click R, it will be red color, G is green color, B is blue color. So that's how it works. And now let's see like how does rules engines work. Now if I create a rule and implement that along with this device gateway in the IoT core, what will happen is like this is the rule now. So whenever I click on B, it will convert it to G, and that's how it will work. And we can enable or disable this rule. So when the rule is disabled, like if I click on blue, it will still be making it blue. But if I enable this rules engine, if I click on blue, then it will convert it to green, and then that's how it works. Similarly, like uh, we can have like multiple rule actions, which is like if we want to store it to a database or trigger a Lambda function or send a notification. So this is like, this is what is here. For example, whenever I click on R, it will send, I mean, it will forward the message to all these 3 things, to an SNS, to a Lambda function, and then as well as to the DynamoDB. So let me click on R, it will just look like that. It's like an emulation of that. When I click on green, it will make the bulb green, but it will not do any action on this. Similarly for blue as well, like because it makes it green, but it will not trigger all these 3 things. Okay, so what happens if the subscribing device, for example, the device 2, if it is not connected to AWS Core at that point of time, if device 1 sent a message, but because device 2 was not online at that point of time, it didn't receive that message in order to perform the action. So that's when device shadows come in very handy. So what device shadow does is like it creates like the uh, backup copy of the actual device on the cloud. And this is how it works. Like for example, let's say if my device 2 is not connected, so I have disabled it. I click on red, so it has made this device shadow as red color, and then it also, because there was like this rule function that should send a notification and store, it did that part as well. Now if my device 2 comes back up online, it will automatically try to connect to AWS IoT, and then the device shadow will update its state to the latest state whatever device 1 has created. And let me disable this, make it green. So earlier it was like red, right? So if I enable this, it will make it green here. So that's how it works. And now let's create like a simple quick rule. So I'll go to rules and then create a rule, and let's say like store to DynamoDB. And then let's say this is how we create this SQL query. We say like select all the attributes of the message that we receive from this topic called bulb 101 PUB. And then what we want to do is, let's say I want to store it, insert it to a DynamoDB table. Currently, I may not have a DynamoDB table, so I'll have to create one. So create new resource, it will open up the DynamoDB service page for me, and then let's quickly create a table here. Let's create a table, and then table name, let's call it sensor data, and then partition key. Let me call this like UID, and then create. Okay, this is being created, and then we can go back to rules, and then here I refresh it, and then I have this table I selected, and then we need to grant IoT Core a role so that it has the permission to put the data into DynamoDB. Currently, we do not have one, so I'll just click on create role, and then I'll call it IoT Core to DynamoDB. Create the role. Okay, it's already there, so I'll create IoT C to DDB. Create role. It has created one, and then let's say add action, and then click on create role. And now in DynamoDB, when I go to items, like there are no entries here, but I have to, like, whenever I send a message, I have to make sure that it has this particular attribute called UID. So I'll come back here, and then I'll go back to my bulb thing. So I have this mosquito publish, and then in addition to client and name, I'll also have to add UID, and let's call this entry one, something like that, and then I'll send it. Now what will happen is, like, it will go to IoT Core, and it will also have, like, the rules engine will have triggered it. So if I refresh this, there has to be this entry which says, like, that's how we keep storing the data on AWS IoT. I mean, we store it on DynamoDB. And let's say if I want to send a notification, we can do that as well. Like, just like how we created this DynamoDB, we can also say, like, add one more action, and then let's say I want to send notification, SNS push notification, and then create action, message format, let's say raw, and then I do not have, okay, let me create an SNS target. So I'll call this send mail, and then click on create. Okay, to this SNS topic I'm sending it, and then I want to use the same role, but let's say I attach a policy to that role itself. Add action, and yeah, that's done, but we will still have to, like, uh, go back to SNS and create the subscription, because what we just did was, like, it would have created the topic but not the subscription. So when we go to SNS, like, we should see, like, send mail topic there. So we will have to create a subscription for that. So send mail, there's no subscription. So click on create subscription, and then let's say protocol email, and then let's send it to my email. Create subscription. It will send a confirmation mail that I just have to accept in my email box. So come here, and then okay, confirm subscription, and then we confirm the subscription. Now that it is done, so any message that goes to that particular topic, we can uh, send notifications. Actually, what we should have done, like, whenever we send push notification, is, like, we should have also added, like, a where condition. So we say, like, select all attributes from this topic, and then just like the SQL statement, where a particular attribute is beyond something, or if it is equal to something, then we send this push notification. But because this is just the demonstration, I'm just going to go ahead. So this is the DynamoDB, and then, okay, let me come back and then go here. So let's say I send the message again, but I'll change the UID to entry 2, let's say. So this will publish the message, so I can see that reflected in my DynamoDB table here. And also it will have triggered the email. So if I refresh my mailbox, I have received that email here. So that's how we use the rules engine. And if we want to work with the device shadows, like, there is this documentation on, it just depends on, like, which topic do we publish it to. So if we are publishing it to this particular topic, like AWS things shadow, AWS things thing name and shadow slash update, so we will have to add this term as well here. If we update to that, it will make that message as the last known shadow for that particular device. So that's how we work with these things. But I also have like some demonstrations of how to work with the actual IoT devices. So if you can just go to my YouTube channel, there I have demonstrated how can you get an ESP32 device to connect to AWS IoT Core. So an actual microcontroller will be able to publish messages to the AWS IoT, and then you can create rules there so you can configure what you want to do with the data that you collected there. Thank you.